Okay, for question number 2 just now. Now we have the speed which been set to 1800 RPM. You can see here the speed been set to this point. Means that we are assuming that at this scenario whereby when the current flows into the circuit, so you have the circuit here, the circuit, 60 ampere flows from generator towards our terminal voltage at 110 volt. This shaft being rotated at 1800 RPM. So what is the IF at this time? That should be set to the RF such that we are producing 60 ampere with 110 volt with 1800 RPM. So how much this one? IF. So we have learned on the step of from IF, then we obtain E naught, N naught, E no load, then speed at no load, then goes to E at full load, and speed at full load. Now we are facing the reverse step of this one. So we are given in terms of E full load now, E full load, speed at full load. So we have to do the reverse calculation to get IF. How much IF? So that's the concern now. Okay. So from the backward here, what we need to do is that we try to find the how much actually the internal generated voltage of the circuit at full load. So we know that our EA is equal to VT plus IARA plus RS. Because this one RS being given, so RS have to be calculated as well. Okay. So at 60 ampere at full load or at certain voltage, full load is 110 amp, but it was stated over here we have to calculate or we have to consider at 60 ampere. So the same goes to the formula. So EA at 60 is equal to terminal voltage that at 60 ampere as well, plus the current IA times RA RS. So VT given 110 volt here. Meanwhile our current is 60 ampere. So we put here 60 amp times 0.2 plus 0.01. You solve one by one. So you get 12.6 ampere. So 110 plus 12.6, we got 122 volt of internal generated voltage at this level, at this current amount. Okay, so 122.6 volt. Then you put inside the equation of generic formula for generator and also the motor. EA full load divided by EA naught equal to speed at full load or speed at certain value divided by base speed. So we have known that the base speed of our system is 2000 RPM, but the EA naught we have not obtained yet because previously we find EA naught based on the IF, and we find IF, then we find EA naught. Now we do a reverse. So we don't know what is the IF yet. So EA naught we have to obtain first, then we are able to find the EA naught. The IF. Okay. So EA naught is the unknown. So it is an unknown. So what we do here, is that 122.6 that we calculate just now. EA full load divided by E naught equal to speed at this full load or at this certain load divided by base speed. So base speed per graph that we've been provided is 2000 RPM. So we find EA naught come out with 136.22 volt here. So we get 136.22 volt of EA naught. So from this EA naught, we refer to the graph of EA versus IF. Previously, we have IF, then we find EA. Now it is a reverse. We got EA, we find IF. Okay. So with 136.22 volt, so if you refer to this graph, 110, 20, 30, 40. So 133.2 is here, around here, 133.2. 130, 135, so 133 like that. So it goes to here. So almost how much? This one. 133.2 we got as 6 ampere. And sorry, 136.2. 136.2. 136.2. So 136 around here lah. So we get 6 ampere as our field current. The required field current to produce such EA. And 136.2, we need 6 ampere to produce 6 ampere to produce this one, EA naught. So go back to the IF formula. IF equal to VF divided by R total. So 6 ampere equal to the field voltage 150 divided by total resistance of 30 plus the adjustable resistance. And so we try to find out what is the adjustable resistance we need to set such that we are producing 6 ampere. So when we calculate, it seems that we need to reduce further down. Means that if we set at 0, we are able to set from 0 to 50, 50 ohm, or what? 60 ohm. So even though we set at 0 ohm, still we are not able to get 6 ampere. And because previously we calculate, if we set at 0 ohm of R adjustable here, the amount of IF only we get at 5 ampere. So this is the issue. So the comment is that RF need to set at 25 ohm. So if you set at we need 25 ohm to get 6 ampere. Or the speed need to be increased. So we now are setting at 1800 RPM. And so if we need higher EA, so we need to increase the RPM. Or we need to increase the VF. The V at the terminal here. V at the field terminal here. So the V at field need to be increased because our requirement is 6 amp of I field. So with 6 amp of I field, we are producing 136.2 volt of EA. So that's the 3 method, 3 suggestions need to propose such that the output of the system are able to deliver 110 volt at 60 ampere. 60 ampere, 110 volt. So that's the what's so called suggestion you need to highlight. Okay, I think there is some, because this question I'm not sure from whom, but there is some maybe some mistakes or what, something need to be corrected lah. Because stated here, explain the method of controlling the speed of DC motor. DC motor, we are talking about generator just now. So this is generator, but stated here DC motor. So maybe some parameter need to be changed lah. Okay, anyhow, that's the, from this scenario, that is the solution. Means that we are not able to produce from the current setting. The required output cannot be produced unless we have to change. Either we change the RPM here, or increase or reduce the RF itself. RF need to be reduced, or we have to increase field voltage, because our requirement is 6 ampere. Okay, I hope I have explained the all the I have discussed throughout the question now. So if you have any question, you may ask me directly from WhatsApp or whatever lah. You may text me. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.